Hey, good morning, everyone. How's everyone doing today? Good. You know, I've been speaking at NDC for about 5 years now, and this is one of my favorite conferences. I want to express a lot of gratitude towards the leadership crew who runs this conference. They always make us as speakers feel like we're at home here, and that's really special. Like, I know a lot of us give talks at hundreds of conferences. NDC is, again, really special how they treat us. I want to say thank you to all the folks who made this conference happen. So I've been doing application, let me get a preset, I'll introduce myself in just a moment, but I've been doing application security for about 20 years. I've been a professor teaching developers how to write secure code for most of my adult life. And this is like 20 years of knowledge that I've built up on the topic of how to write secure code, but like in any company, that knowledge comes and goes as people come and go. And it becomes hard to preserve the knowledge of how to write secure code in any organization. Now, artificial intelligence shows up on the scene. And in a matter of just a few years, this technology has become incredibly transformative. But the problem is, if you're a senior engineer and you start using artificial intelligence to write code, what are you going to find out really quickly about how AI writes code? It writes it poorly. It does it fast. It sometimes does things that are really good, but the quality is mixed. And a lot of senior developers who play with AI and experiment with it, they see the mistakes and dismiss it as a junk technology and give up on artificial intelligence. This is the worst career move you could possibly make. Software engineering is changing rapidly before our eyes. And the way that we wrote code even a few months ago is going to disappear in a short amount of time. But you need to learn how to use artificial intelligence correctly. I see artificial intelligence as like a really sharp new engineer who knows nothing about your style, your culture, or security. But they're a smart engineer. And if you teach artificial intelligence what quality is, what good code is, and what security requirements are at a meticulous level, you're going to see this technology go from being garbage to being transformative in terms of how you write and review software. And this is the bleeding edge, I got to admit. If you look at a lot of the studies out of universities, out of governments, and from personal research groups who are using AI to write code, what does every single study to date say about AI writing code? They say it's poor. And this has become like an overriding idea. The problem is what none of these studies do, none of these studies show you or try to teach AI to do better. And so right now, in general in the world, I think everyone in the world who's looking at and studying AI for code generation is missing how to use it correctly. There's a group of people, though, in different organizations. I see a lot of the gaming industry using prompt engineering. I see some small groups here and there using it. But I want everyone to take their current expertise, teach AI how to do better, and you will never write code without AI again. And the good part about this is, remember, your security engineers, they come and go, and you lose that knowledge. But now when you have a security engineer in your team, you take their knowledge and convert it into prompt engineering instructions, and you will preserve that knowledge for all of history. So the benefits that AI provides in code generation when you use it correctly is going to transform our entire industry, and it's already happening today. It's time to join these methodologies. Now, a lot of people talk about this, but I want to show it to you in a real framework. So I'm just picking an arbitrary framework that's popular today, that I use a lot in my own work. That's the React JavaScript framework. We're going to look at what React is, because AI for code generation starts with having security engineering knowledge. We have to some human within your team needs to understand how to do React securely. And what we're going to do is we're going to take that knowledge and convert it into prompts that we can reuse over and over and over again with different engineering members of our team. It's a picture time? Hey, how you doing? So there's challenges we're going to look at. We'll look at these different strategies of how to do React securely and convert that knowledge into prompt engineering instructions. If I have time, I'll give you a demo as well to show you this in the real world. My name is Jim Manico. I've been a software engineer for almost 30 years. I focus on security engineering. I'm a published author, but who cares about me? What we care about is, let me try to help you use AI better in your own work tomorrow. So let's look at the AI prompt engineering lifecycle. Number one, you need a priori expertise in your team. Someone on your team is a team lead. Somebody on your team knows security. And we want to take that security knowledge and convert it into rules that are verbose and written by a human being. And we're going to save that under source control. Then we're going to convert those human rules for secure engineering into prompt engineering rules. The way a human describes a security characteristic of code and the way AI needs it to actually write secure code is going to be a bit different. So I have a human expert architect write the rule verbosely. I ask AI to reduce it into something they'll understand, and I'm going to preserve both of those sets of knowledge under source control and maintain it over time. And then I'm going to take my prompts, I'm going to throw it into an AI engine, write code, and then send those rules into an AI engine again. This is important. A lot of folks miss this, and it's a big way to power up your code. When you build these prompt engineering rules, you apply them before and after you generate code and then analyze the code. Because some rules are going to fire better before you write the code, and some rules will fire better on existing code. So that's my life cycle. And your prompts are going to have errors in them. But these prompts are going to become more valuable than the code you're writing. So we keep those prompts under source control and maintain and update them, possibly for different engines over time, and you will never go back to manual coding ever again. The average developer who's his entry level using AI, they get like a 3x bonus. But if you take a senior developer and architect and teach them how to use AI with prompt engineering, I see benefits around 100x of my normal coding speed. I'm pulling off 6-month projects in a couple weeks because I have good prompts to do it right. And I iterate these prompts, I refine them over time, they get better over time, and I see them working effectively in all the major engines. Claude from Anthropic, ChatGPT from OpenAI, and even Gemini, especially for Google projects. So again, we identify security requirements and describe them verbosely as a human. We then use AI to translate those instructions into AI prompts, which I'll use against the AI engines. And then we deploy those prompts before and after we write code, and then we iterate on these prompts to refine them for our team over time. And I think this iteration process is important because, there's one rule I want to do URL validation in React. And I wrote this rule to be like paragraphs long, and until I said the words, do this in React, the rule didn't fire properly. So you're going to have to experiment with these rules to get them to really be effective. It's not that difficult. It just takes iteration like any other engineering project. Now, before I focus on security, I have prompts also for quality, which has really transformed how I'm watching AI write code. So there's a couple metrics that I don't think a lot of us have heard of before that are going to be really effective in teaching AI to build you maintainable code. Because we're not writing code for a computer. If that was the case, we'd be doing assembly, Scott, right? But no, we're writing code for other humans to maintain. And we still want humans to understand this code that AI is generating. So I ask AI to do 3 things for me: low cyclomatic complexity, low cognitive complexity, and a high cohesion at the very least. These are very obscure static analysis metrics, but here's why we use them. And these are my prompts for quality. Maintain low cyclomatic complexity. This is code that is going to be easy to understand, easy to test, and easy to maintain because it has a small number of linear paths through that code. The problem I see in a lot of mid-range to senior engineers is they're now trying to prove how cool they are. That's like 10 years of my own career. I wasn't concerned about the next person maintaining that code. I wanted to stretch my mental muscles and write super clever code. when I find engineers like that, like if I was working with my old self who wrote code like that, I would throw myself off the building because it makes it hard to maintain. So I want code, as a now, like 30 years in, my code is dumb, simple, easy to read, because I want the next guy to maintain it easily. That's, in my mind, good engineering, and these prompts will give me that. Low cyclomatic complexity, low linear paths. Minimize cognitive complexity, easy for humans to maintain and understand. And high cohesion, it makes sure that all these components we're building are logically grouped, so it's easy for a human to understand why I've built these modules for my code. These are my first 3 prompts. I have several more that I can show. Let me bring this up for a second, see if I can find this. So, other prompts, give me one quick second to fire this up. Let me show you the full list here. So hang on for one sec. So we're looking for, there's the rules. Here we go. Let me bring this over to the other screen here. So here's like my mega list here. Maintain low cyclomatic complexity, minimize cognitive complexity, avoid code duplication, do high cohesion, do loose coupling, so components are easy to extend and easy to use without having to modify them over time. Use clear naming conventions. Stop using X, Y, and I, please, right? Follow proper component design. Ensure accessibility for different legal purposes. Prefer functional components that are easy, again, mostly for maintainability. AI will not do this unless you ask, right? My original rules were multi-paragraphs long, and I got AI to reduce them, and these all fire very effectively. So that's the first set of rules. Quality characteristics, very obscure static analysis metrics that work. What it does is it changes the AI database and changes the weights of these mammoth vector databases to prefer code that has these qualities. The other things we can do is be specific, explain the context, include constraints, and for certain kind of rules, I struggle for them to fire correctly, so I provide a small code example in my rule system, and that problem goes away. Like one of the things we'll look at today is, I was really struggling to get my URL validator in React to fire properly. And so what did we do to fix that? So what we did to fix that is data handling, ensure outputs, enforce safe usage. Let me show you that just a little bit later. I'm getting a little sideways here. We'll come right back to that. But let's actually talk about React for a moment. So React is the #1 JavaScript framework in the world today, right? It's kind of won the war of the user interface battle because it's a lot easier to use than Angular. Angular is a challenging framework in my opinion, expensive to maintain, and it's built for developer ease of use. Maybe not as good as Vue, but it's somewhere in the middle between security and functionality and compatibility with other frameworks and ease of use. Most React developers I know, they really enjoy working with it because it's so flexible. So the problem with React, though, is twofold. A lot of developers don't realize that their React code is running in the browser. And I can go view source and see everything you're doing. And there are certain things we should never see in React code. Can anyone think of something? Scott? What should I never see in client-side React code? Secret. A hard-coded secret. How much access control should I do in client-side React code? Absolutely none. But developers make these mistakes every day. So I want to make sure that in the source code, certain things just don't belong there, and they're not there. So what about the other risk? Content injection, cross-site scripting. When I tell a developer, I can do cross-site scripting through your escaping mechanisms. They're like, that's not possible, that's our security. I'm like, yeah, it's flawed in certain ways. So I'll show you how, even when you think you're doing good React with mustaches and JSX, I can bypass that and still do script attacks against a React application. And the thing is, once you understand how this can happen, then it's relatively easy to fix that code. And we'll show you how to do that and then prompt it so AI gets it right. And I recommend you, and the goal here is not just teach you React. The goal is for you to repeat this process for every framework you care about. And now you can help your junior and senior engineers use AI as a coding buddy to speed up their productivity. So what's wrong with this? We have a hard-coded secret. Number one, I can view source and see that API key. But what about this? If the user role is admin, then show the API key. How much security does that provide us, Scott? Say it. None. I view source and see it all. So I want to make sure AI never does this. I want to make sure human developers never do this, right? In fact, there's a lot of things I should never see in your React code. Hard-coded secrets, no access control at all, no use of old-school React lifecycle methods. They're script attackable. No direct DOM manipulation with a ref. No use of eval. No props or types raw from user input. No storing sensitive data in local or session storage. No using old third-party libraries. No misusing libraries, and no use of URLs as a parameter without client-side validation. These are things I don't want to see in code. But let's take a step back. Let's take a look at like cross-site scripting. Cross-site scripting is real. It's something we have to get right. In fact, MITRE recently released the top 25 software vulnerabilities, and guess where they place cross-site scripting? At number 1. Do you agree with that, Scott?
Volume of attacks.
It's pretty compelling, right? But we saw British Airways get popped with XSS that led to like one of the largest GDPR fines in Europe. We saw Fortnite have XSS, which led to 200 million records being stolen, a lot of that data and private data about children. We saw eBay with XSS that would let me edit a seller listing and modify it. So these are big impact attacks. I care about XSS. I want to get it right. Let me look at stored XSS for a moment. All this is I submit data to your database. That script is implanted in your database. Another user views your website, pulls down that data insecurely, and as an attacker, I can get an evil script in the browser or web page of another user. Cross-site scripting, old school vulnerability. Let me show you some examples of cross-site scripting, just to give you the context of what this attack is. Here's an example of an attack that will extract a cookie and send it to a server that I control as the attacker. This will let me harvest your cookie, hijack your session, and take over your account. Here's another attack. Here's an attack where, again, I would submit this script to your application. Another web page would be rendering this data without security. And in this case, I can take all of local storage, all of session storage, stringify it, add it to a URL, and send it to a website that I control as the attacker. And a lot of developers put session tokens and sensitive data into their local and session storage. It's trivial for me to steal it. And if I was going to make this a real-world attack, I'd minify this code to make it more concise. Here's the real attack, though. If you look at Google research, what are attackers actually trying to do? They're trying to do request forgery with cross-site scripting, because all of your cross-site request forgery defenses are useless in the face of this attack. Imagine that you and I are logged into webmail together, webmail.com together, and there's a vulnerability in how webmail renders your message or renders a subject. I can put this in the message or this in the subject. In this example, the website was blocking script tags, and I couldn't get this attack to work. So I just changed the first letter to uppercase, and I bypassed their very poor security rules, right? And what this does, what does this attack do? This attack forces a user to send an email. It's doing image.source, that's a GET request. And it will send this request to the boss and send this email with the subject that calls your boss a jerk. This is not good for professionalism, but this is the real attack that attackers do. If they can get XSS in your web page, they can force you as a user to make any request or requests that the attacker wants. I can do other things with XSS, like do a keystroke logger. In this case, I'm trapping the key down event and using fetch to send it to my attacker server. In this case, I'm doing full site defacement, document body inner HTML, and override the entire page's content. And the reason why we can't filter or block this attack is because JavaScript is insane, right? I can represent JavaScript in so many different ways. This is an alert field, right? Do you see it? You see it's got alert 1, right? That's actually a real chunk of JavaScript that will execute. I can even do XSS with no numbers, with just special characters. It's very verbose, but I can do it. And the problem is to build a firewall or a validation layer that can block these attacks without stopping real data is not an easily solvable problem. If anybody can build me a firewall that reliably stops XSS without breaking functionality, you have a multi-billion-dollar company. No one's been able to do that to date. You dial in the rules too tight, you're blocking good data. You dial in the rules even a little bit too loose, and I can script and I can attack through it. So we can't firewall or validate our way through this problem. We have to actually build secure user interfaces. So let's do that in React. We're going to understand how React stops cross-site scripting. We're going to look at dangerous URLs. We're going to look at rendering HTML in React, securing embedded JSON, dangerous styled components. We'll look at insecure DOM access, access control failures, vulnerable third-party libraries, open redirect vulnerabilities, and we'll look at insecure server-side rendering, the top 10 problems we see in React, and we're going to teach AI how to get all of this right the first time we write code. Let's start with cross-site scripting. So the way that React stops these problems is by using the auto-escaping template JSX. JSX is a great secure template language that's used in React, in Vue, in Svelte, and other frameworks that help drive the web today. And a lot of developers depend on this for security. When I tell a React developer that I can attack you through JSX, rarely do they believe me. I'm going to show you how in just a moment. So when I have a raw attack, that's the attack at the top. When I add that to a web page raw, that will lead to the attack executing. When I put that same data through JSX in my mustaches, it's going to escape the attack, which we see at the bottom. And the difference in the attack at the bottom is it will display the code without executing it because it escapes the characters. You look at the script tag at the bottom. That's no longer a script tag. That's a less than sign, the word script, and a greater than sign. That will render the code on screen without executing it. In every framework, escaping is one of the hearts of how to build a secure user interface, either by the framework or with libraries or doing it manually. We need escaping to stop XSS. So far, so good, everybody? So how do I prompt this? Here's my instruction. Always place user inputs inside JSX with curly braces to prevent XSS. And the second sentence is what really enforces this rule. Avoid unsafe methods that bypass React's escaping mechanism. Rule number 1 to use React securely in our list of prompts. And again, what am I doing with this? I'm keeping this under source control, right? I'm keeping this well maintained. I care about this. This is a main artifact to drive security through my organization. Next, what do we have? We have, how do we create components in React? The main function to build a component is create element. There's 3 arguments. The type, which is your HTML tag, the props, which is your HTML attributes, and the actual children, the actual data. The third argument is what is meant to be user-driven data. The third argument is your display data. And the third argument is going to escape automatically, just like you're using a mustache, right? But the first 2 arguments, they're not meant to be user input. In fact, the first argument is your tag name, like a div. If you put a user variable into that first argument, it's going to render raw, and we have cross-site scripting. The second argument does escape. But if I put data in the second argument from a user that lands in an on-click handler, even though it's escaped, an on-click handler and an HTML attribute will decode and execute. So if my data in the second argument, the prop, if that lands in an event handler that executes code, then we're back to XSS. And these are difficult problems to get right because a lot of developers they'll use user data for all of these mechanisms. So how do we get this right? Let's prompt it, right? So first of all, one note first, Our untrusted data can only land in a safe attribute like ID or class. These attributes don't execute code. We want to avoid functions like onClick, onBlur, and similar that do execute code. I also want to avoid putting untrusted data without validation in a URL loader. If you're only checking if it's a valid URL, then I can use a JavaScript URL to bypass data that lands in a URL handler. So let's prompt it. Number one, validate React create element types. Make sure only safe, expected HTML tags or React components are used. Avoid dynamically generated or untrusted input as type arguments, right? Prompt engineering. Also, validate your props. The second argument, use prop types to validate all props. Avoid passing props into executable attributes like onClick and onload, and sanitize and escape props using URL-related attributes like href and source. I started with a 2-paragraph explanation, and little by little, I whittled it down to the essence that all 3 AI engines of the day are going to fire properly on. Other things that can go wrong in React are using dangerously set inner HTML on untrusted data. Hey, Scott, if you're using dangerously set inner HTML on untrusted data, what kind of life are you living?
Terrible.
What's the first word in that? You're living a life that is? You're living dangerously, right? It's a common anti-pattern in React. Or if you're putting a user URL in a mustache, I can use a JavaScript URL to bypass React. If I'm putting raw data into a styled component, or if I'm putting a piece of JSON on page with Stringify, or if I'm dynamically building a template server side, these are all the major anti-patterns that lead to insecure React. But we're going to fix it at the AI level. Let's look at the first major violation of React, the dangerous use of URLs. Now, I looked at a lot of research from Google around how Google is actually attacked through this mechanism. Google publishes a lot of their data on security research. This is like Michelle Spagnuolo, Lucas Weichelbaum, Chris Christoph. They're all scientists and programmers, and they track, study, and publish data about these attacks. Google tells me, Spagnuolo tells me, 1/3 of all successful attacks against a Google property is with a JavaScript URL. So this is like one of the biggest areas of weakness across the web, the fact that browsers handle JavaScript URLs. This is such a big problem, I did a proposal to the W3C, give me a response header that just disables JavaScript URLs, and because of content security policy, they're hesitant to do it. I still think we need that though, but I digress. So let's take a look at this now, hang on. So here's an example of like a user profile. I have a social media website, right? And so I'm asking you, what's your first name, what's your last name, what's your address, what's your company, and what's your homepage? You give me your homepage, and when I render your profile, I'm going to convert it to an anchor tag. I'm going to convert it to a link. So when you look at your profile, your homepage is linkable. And I would do it like this. You give me your homepage, I'm going to validate to make sure it's a legal URL. Then I'm going to put it in this third line, this little chunk of React JSX. Anchor tag, href, is the homepage in mustaches and your homepage link. The problem is, here's my bypass. That bypasses React. Here is a JavaScript URL, and that is a legal, valid URL. And what's it going to do? Document body inner HTML. Dogs are awesome. I'm a cat person. Jim's cat pictures. I'm more of a cat person. This will fully deface the website and bypass all of React security, and we're done. So here's another example of this problem. Here I have a button that has a form action with the payload. And that payload is under JSX. It's getting escaped. This is not the right control, though. This is not the right defense. Because I have a JavaScript URL that lands in a form action attribute. It's encoded, but what do attributes do? They automatically decode and execute any attribute data. That's how the web works. So this is a major vulnerability. Escaping a URL doesn't help you. The answer is, I got to validate it. And it's not just me trying to say this, right? Here we have ESLint, where I've applied the React and security rules of ESLint. Look at what it says. Script URL is a form of eval. So any linter worth its weight in salt is gonna, if you put a URL in an href or active attribute, it's gonna complain you should not do that, and I agree. So even linters will specify this. So again, this is the problem. How do we fix it? How does Angular handle this problem? Anyone know? If you try to put an active URL into Angular, what does Angular do? It will automatically block a JavaScript URL, whether you want it to or not. It's built into the framework. And I give Angular a lot of credit for this. They have all these security weird mechanisms built into their framework. The only problem is it's kind of over-engineered. It's very expensive to maintain Angular code. So even though I like the security of Angular, it's React where most of my customers write code and they run into this problem. Well, here's what I recommend you do. Do URL validation not on the API. Do it in React. Because if you're going to build a really secure React application, here's your mission. We call it perfect injection resistance in academia. I made that term up, so anyways. So perfect injection resistance. What that means is no matter what data you feed into your React UI, injection's not possible. I never make an assumption ever that your API is going to hand me data that's safe. This is a good assumption to make. So I want every variable, even if I'm doing good URL validation on the server, I don't depend on it. And just like Angular, I do it in React with this function. In fact, my React rule specifies this exact code so it consistently does the same validator. I check if the URL is valid. I make sure the protocol is only HTTPS, and any other input, I'll just put a placeholder, the pound symbol. And now this problem goes away. So anytime you let a user drive a URL that you're going to link up or use in your client for different purposes, this is the mechanism that will protect you. So what is the rule in React, right? Strict URL validation. Accept only secure URLs with the correct syntax. Validate any user-driven URLs used in client-side React code on the client and replace the URL with the pound. If it's not valid or HTTPS, use the native JavaScript URL class and not a regex for this purpose. Here's an example of the function to use. Bang. This is my exact rule. I've noticed that when I apply a general rule, AI builds a different validation function every time. Sometimes they use a regex, sometimes they accept HTTP. So I'm like, I'm done with trying to get them to get this right. It's such a critical utility function. I put it in my rule, and AI has never gotten this wrong since. So this is, sometimes I need code samples for utility functions that I demand AI do for me. There's our third or fourth prompt of the day. How about rendering HTML? One of the things we do as developers is we use WYSIWYG editors like CK Editor, TinyMCE, or if you're really one of the cool kids, you're using Friola, beautiful piece of library code. So here's TinyMCE written by a guy named Spock, been maintaining it for 20 years. Neat little framework. It's a WYSIWYG editor. Like a word editor, I can apply this library, TinyMCE, to a text area that lets me do different font sizes, colors, embed images like a normal word editor. When you hit submit on this form, it submits a big chunk of HTML. How difficult would it be for me as an attacker to modify this HTML and add JavaScript to it? Would that be hard? No, use Chrome Dev Tools, use an intercepting proxy, whatever. This is not that difficult. How do I, and here's the other problem. When I'm trying to render user-driven HTML, if I put that in a mustache, which is default in React for the most part, then I'm not going to see the rendered HTML. I'm going to see the code. It's going to be secure, but the functionality's broken. So how do I disable escaping in React? You got to live dangerously. Dangerously set inner HTML will disable the escaping and render the HTML. But this is dangerous because I can modify the HTML as a user with ease. So the traditional answer when it comes to rendering HTML from a user safely is to use a sanitizer. And the big one of the day today is DOM Purify by Mario Heidrich, right? So if I'm going to use dangerously set inner HTML, I got to make sure it's safe HTML by just using DOM Purify and keep this library up to date. You can even get more specific and limit which URLs DOM Purify uses to load images, or I can limit what tags DOM Purify allows you to render. But you don't need to do this stuff. Just plain out of the box DOM Purify completely stops injection attacks. And again, anytime I'm using dangerously set inner HTML, I'm absolutely going to sanitize it. Now let's teach AI to do the same. Nice and simple. Minimize the use of dangerously set inner HTML. Avoid this method unless it's necessary, and sanitize content with trusted libraries like DOM Purify. Picture time, excuse me. Thank you, sir. All right. What else do we have here? So let's secure JSON next, right? So if you look at the original documentation of React, this is the original Redux document. This is now back like over 10 years. Redux is the state management mechanism of React that we actually don't need anymore. So what they said was, how can you make a page in React render even faster? Right? Speed matters for certain applications like e-commerce and similar. So normally, I'm a browser, you're a server, I make a request, I get HTML. I make a request, I get my JavaScript. I got my React framework, now I make an XHR hit and get that JSON. Each extra hit adds latency. Especially on a mobile network, this is a big problem. So what Redux recommended we do is, we put the initial JSON embedded on the page to save one XHR or fetch round trip, and you get faster page performance rendering time. There's a neat little performance pattern when it matters. It's not necessary. It'll save you a couple hundred microseconds. That matters in certain applications and certain kinds of network. The problem is, the original Redux doc said to use JSON.stringify, which is a plain text rendering of a piece of JSON. And this is a big problem. So what we do, like for example, here's my bypass. I have the address field, and I'm going to value my address script, end script, and an alert. This literally is a piece of code that when I'm displaying JSON raw in a page in a script block, it will execute a payload. So those Redux docs from the beginning of the React era actually put this insecure pattern in millions of developers' heads, and I see this repeated over and over again. So the way we get this right is relatively simple. If I really want to pre-embed JSON, then I'm going to do this instead, right? I'm going to go encode for JavaScript that JSON, and now even dangerous data is encoded into JavaScript, so I can embed that initial JSON safely without the risk of script execution. It's a relatively simple technique. I want my JSON quoted and escaped for JavaScript, and this problem goes away. What do we do next? We prompt it. When embedding the initial JSON on a page for performance save a round trip, use safe encoding techniques like JavaScript encoding to safely embed JSON on an HTML page or a React template. Avoid protecting JSON with stringify to prevent XSS. You got it, right? Pretty simple rules. Let's keep going. Let's talk about dangerous styles. CSS injection is a real problem in React. Here's some examples of it. Here at the bottom, I have a user profile. I'm using PHP to echo a certain color. That's an open piece of user input. I can end the style, open a script, and attack this page pretty easily. Back in the day, I could literally use CSS, which is supposed to be a style markup language. I can build a keystroke logger out of CSS. You ever see this, Scott? This is mind-boggling. The browser has fixed this long ago, but I can use CSS to say, if the input type is password and the value is the letter A, then load the background image and send the letter A to my attacker server. This is mind-boggling that this even works. The point I'm trying to make is CSS injection is a real problem in React. And the problem is I'm using, this is not JSX. If you have mustaches, that's JSX. $ mustache is just a string replacement. So this is XSS all day. And the way you fix this is with CSS escape. Guess why a lot of React developers won't do this on inputs in a styled component? Guess which browser doesn't support CSS escape? That would be Internet Explorer. So to satisfy Internet Explorer unit testing, developers would not use this function. This is nonsense, right? IE is dead, thankfully. IE's been end of life for years at this point. So the answer is use CSS escape. Here's an example of it right there. Element style set property, a certain variable in CSS, and use CSS escape. The fix is pretty simple to get this right. And so is the rule. Escape dynamic CSS. Use CSS escape for dynamic content in styled components to prevent CSS injection attacks. Nice, simple, clean rule. What else do we have here? Let's talk about insecure native DOM access. Please don't edit the DOM with the ref. What's a ref in React? That gives me direct access to the underlying DOM underneath React's virtual DOM. And when you're using a ref to edit the DOM, you are literally bypassing all of React security, and your code's a bit messier too. So you can use a ref for just a couple things. Programmatic focus to do autofocus on a component, something called a click-away handler. If I want to do programmatic scrolling, these are read-only kind of mechanisms that don't modify the DOM. Find DOM node for read access, that's fine. All I'm saying is don't edit the DOM with React's refs. Now, a lot of developers don't like that advice. They can't stop, they won't stop. So if you're not going to listen to this advice, I'm with you, then use safe JavaScript to populate the page. Things like text content, the dot value, create text node, none of these functions will execute code. In fact, I can also take something like inner HTML, which is mammothly dangerous. This will render HTML JavaScript and execute it. And so for inner HTML, to make that safe, how can I make inner HTML safe? What do I need to do to content to render HTML to make it safe? We just talked about it. Sanitize it with DOM Purify. I've taken a lot of legacy JavaScript apps that use this old framework called jQuery. Oh my God, jQuery hurts me. I mean, it's so insecure. But I went to an old jQuery app for a friend of mine in India, and it had like thousands of XSS. We just lit up the entire app with DOM Purify on every variable. The functionality was unbroken, and all these problems went away. It's kind of ugly, but it works. This is great library for legacy remediation. And remember, we only want to drop data into a safe attribute or only valid URLs with the right protocol into a URL handler. So let's make a rule. Safe ref usage. Use refs only for reading the DOM or use cases like focus handling. Avoid refs to directly modify the DOM. Nice, clean, simple rule that fires in all three engines of the day. And this is, for me, these rules are version 25 or so. I've gone through about a year of revisions. These are like the 25th version of these rules that are as concise as possible and still fires accurately, right? Access control. I'm running low. We already talked about this in depth. Access control. So restrict client-side access control. Enforce access control on the server side as client-side checks in React can be bypassed. As a side note, when I'm building a UI, I use lazy loading. I put all of my code on the server API. I do really strict access control at the API, and I'll have React lazy load things. Like, for example, if I have a navigation bar with different links, I may have different roles. That nav bar will look different for different roles in my system. So I'll make that nav bar a server-side API dynamically generated with access control, and I'll have React lazy load that nav bar when it needs it, with all the good access control that I built on the server. This is a very common pattern to help support advanced access control. Here's another problem, third-party libraries. The JavaScript ecosystem is a morass of insecure filth, right? The JavaScript ecosystem of third-party libraries, the NPM repository, is, again, let me be clear, a morass of insecure filth. That's the vast majority of the NPM repository. And in fact, the JavaScript libraries are growing exponentially in NPM. Now, my vote is, if you're a JavaScript developer and you decide you don't like React, you don't like Angular, you don't like Vue, you don't like Svelte, you don't like Backbone, and you need to build a new user interface framework in React from scratch, right? If you even think this, I think you should be banned from development for at least 3 years. Okay, let's move on. So these third-party React, that was a joke that nobody laughed at. So third-party React components have no security guarantee, and I recommend that you realize that all of these components have security issues, and we have to go through the burden of keeping them up to date. When I build React, I minimize my use of third-party libraries. I saw a React app that was using 200 third-party libraries. The chance of that being secure is 0 at this point. So we're in an era where we know third-party libraries and components have major security problems. We should be very careful about why and if and what we use in the third-party library world. So also for React components, I prefer dependencies that don't use dangerously, that don't use inner HTML, that don't use raw URLs, or any of the other unsafe patterns we just talked about. I prefer components that use React Markdown, that use the React native APIs to build components that have better security and performance properties. And so I can use all these different tools to scan my app, to check the third-party libraries for security. That's great, but you're better at getting this right up front. And I have 2 rules to beef this up, or 3 rules actually. Rule number 1, only select updated components. Ensure all dependencies are up to date and actively maintained with recent security patches. Rule number 1, pick libraries well. Rule number 2, avoid unsafe dependencies. This is very specific to React now. I have the similar rule specific for each framework I use. Use libraries that avoid risky patterns, like using dangerously or unvalidated DOM manipulation. And here's my 3rd rule. Minimize dependencies. Minimize the use of third-party libraries and generated code, opting for native JavaScript or React functionalities whenever feasible. Prefer built-in solutions to maintain simplicity, enhance performance, and reduce dependencies, improving maintainability and security of your code base. One of the big benefits of not using a third-party library and writing your own code when it's feasible, you now can analyze that code with static analysis tools. You know, like your semgreps and similar out there, the code scanning tools, the GitHub scanning tools. When you're doing third-party libraries, you're not analyzing the code. You're mapping like a hash of that library with the database, and this is not the best way to go about security. So these are my rules. And I gotta admit, of all the rules we have, these 3 third-party library rules, they're gonna be the weakest. So I make sure that when I'm using any kind of software development DevOps lifecycle, I'm always running my code through an SCA tool, a software composition analysis tool that alerts me when I'm using an insecure library. But these 3 rules will help at least make somewhat better choices that will be easy on you to fix and maintain. One of the last problems we have is an open redirect here, right? So an open redirect, like in a login flow, let's look at the source attribute, retrograde.com reviews, right? That might be a page I bookmark, and now I'm logged out. If I go pull down that bookmark, I'm typically redirected to the login page. When I'm done logging in, I'll get redirected back to the source attribute. But as you can see, as an attacker, I can modify the source attribute to be an evil website where I can post a copy of your login page and use it to harvest your credentials then redirect you back to your real home page, and I just stole your credentials, and you don't see it visually. It happens behind the scene. I digress. So I want to make sure that we're doing rigorous validation. How do we properly validate a URL? With a wildcard pattern, with a regex? NITOC. I say no to that, right? Because there are so many ways where I can mess up in validation. Let me see if I can pull this off quickly. I'm not sure if I can, a little awkward here, but the problem here is, let's say here's a very common wildcard pattern in URL validators, HTTPS, right? HTTPS. I got wildcard.scottai.com. How you like that business name? You good with that? So what are we expecting? We're expecting the wildcard to be what? To be something like, site.scottai.com. What would my bypass here be? This validator, this regex, or this validation rule is easily bypassable with this. I've gotten bit here more than once. I'm going to go Manico, and Manico.com/got you. That's it. That's my bypass. So if that's my bypass, let's check this out. And I dump this into right there. I'm at a whole new domain. I just bypassed your validation rule. This is a very common validation flaw that's bitten more than one website. In fact, this problem is so bad that the OAuth 2 BCP, this is the OAuth 2 Best Current Practices for Security, it's the OAuth 2 working group. What they say is, if you're going to do URL validation, then you should use, what should you do? You should do simple string comparison, use an allow list. It weakens your functionality, but URL validation is so problematic, I do highly recommend you do some kind of allow list. Here's how AI writes that code for me. I have allowed redirects. I only allow 3 redirect endpoints. Anything else, I redirect to the error page or back to the home page. So allow list validation is the #1 way to solve open redirect vulnerabilities in code. So validate and sanitize redirect URLs to permit only trusted destinations. Implement a strict allow list for URL redirection validation and avoid using regular expressions or similar methods. Yes. So what else? How about server-side rendering, right? For server-side rendering, this is when I'm using, okay, before I go too much further, I don't want to shock you, but we use JavaScript for the client, right? I found out recently that some people, Seba, do you know some people use JavaScript on the server? I'm serious. Have you heard of this node thing? I lost sleep for a week when I heard about that, right? So if you're doing JavaScript on the server on purpose, right, then you can use server-side rendering with React. Now you're running React on the server to generate HTML and send that to the client. All jokes, the benefit of using Node, Express, and server-side rendering is speed and rendering time. There's no more React rendering in the browser. It's HTML, and the speed of page rendering and response time is admittedly dramatic with Node, React on the server, right? And I don't do much of this, but the way you would do it is with the family of render to functions here, and as long as you're following all of these safe mechanisms and you're using the right render to functions, you're going to build secure React on the server. And so here's the vulnerability. Seba, where's the vulnerability? How you doing, Seba?
In this one.
Yeah, where's the vulnerability on line 16? See, look at line 16. You see how there's render to static markup? That's safe. You see the raw variable counter? That's raw user input being added to the page? That's the problem. We never want to use SSR functions mixed with raw data. This is where things go wrong. So to fix this, we go use the render to string or render to static markup for SSR. Sanitize all dynamic content before rendering to prevent template injection. I'll give you one more here. If you're doing old school Java server pages or ASPX, and what you want to do is you want to convert that to React, many developers do React template construction within that server-side template. And this is an anti-pattern. Because if you're dynamically making a React template on the server mixed with user data, this leads to a vulnerability called template injection. We want to make sure that our servers, our React templates are static templates typically sent to the client and rendered there. So avoid dynamically constructing JSX templates with untrusted data. Use React props and state management to securely handle dynamic content. That's my story. One extra bonus, use ESLint with the security and React plugin, and many of these problems will be discovered at client development time. So I got 4 minutes. Let me see if I can pull this off now. So what I want to do is, hang on for 1 sec. I'm going to be there with you in just a moment. I'm going to give you a very quick demo here. Let me see if I can pull this off. So I'm going to go to ChatGPT, and I am in an open prompt here. I'm going to be with you in just a moment. So here we go. So now I want to open up this here. And I was showing you my older rule set before. This is my new rule set that is much more concise, that fired here. There's the URL validator. There's my current React rule set. So let me get out of here for a sec. Boom. And I'm going to show you a few things here. So demo. So here's my ask. I'm going to say, and this is live on ChatGPT. Wish me luck, everyone. Never do live demos. So create for me a React user profile page with a username, first name, last name, homepage URL, renders the link, profile description, and here it goes. Take a look at this. If we take a look at, again, this is live right now on ChatGPT. And there are the two problems. Take a look at the homepage URL right there. Here's a homepage URL in an href attribute raw. There's vulnerability number 1. And I'm rendering the description with dangerously set inner HTML. There's vulnerability number 2, right? So here we have, and I can show you this exact same demo in all major engines. They all get this wrong. And it frustrates me because it's a very simple problem that they should get right. The problem is most developers get this wrong. That's why the AI engines prefer this insecure code. This is the common vulnerability that most developers implement. So what I'm going to do now is I'm going to fix this with AI. I'm going to go back to my rule set, and I'm going to apply 2 rules here. I'm going to say, number 1, I'm going to put these 2 rules in right now. And I'm going to say, where am I? I'm going to say right down here, I'm going to say, please fix this code using these rules. And they're the exact prompt rules that we just talked about in the class, the exact text that we showed you in the module earlier. Let's see how it works. Wish me luck. Never do live demos, folks. Is it gonna work? I got 1 minute and 40 seconds. All right, there's a URL validator. There's my sanitize function with DOM purify. And here we have the code being rendered that the home page is using a safe URL that goes to the validate URL function, and dangerously set inner HTML uses safe HTML, which went through DOM purify at the top of this code base. Boom, it works. This is my story, folks. Take your existing knowledge within your company around security engineering. Convert those to long-form human explanations. Use those long-form human explanations to build an AI prompt rule separately in each of your major engines. Keep this all under source control, maintain it and augment it over time, deploy these to all of your engineers, and go forth and use AI to radically increase your productivity, to write secure code with better functionality. And this problem globally, where we don't have enough developers to satisfy the engineering need, With the use of AI and the use of techniques, we have a chance to transform the entire world of software development and undo the sins and problems of our past and really build software in a more fast, more quality, in a way that we have enough engineering resources. We can change the world by doing this. Thank you for listening to my story. I am 3 seconds. I am done. Go forth and write secure code. Have a great day, everybody. Thank you.